Welcome to Unit 2, Lesson 1. Let's make a box. All right, so our objective is we're going to investigate the volume of different boxes. So, which three go together? So, if you picked this one, you can say A has no shape. If you're just looking at them, B looks the fattest. But if you calculate the volume, remember volume of a cube equals length times width times height. If you calculate 10 times 2 times 8, you get 160 centimeters squared. Everything else is 320. C is the tallest and skinniest, but this is the only one in inches. The units are different. And in D, they give you the volume, and all of the side lengths are variables. So pick a reason. There is no right or wrong answer. You just had to pay attention and look at it. Okay, so what happened in this activity? What we did was we took a piece of paper, we took a ruler, and we measured 1 inch this way. We made a mark. We took another ruler, or the same ruler. We measured 1 inch this way. We made another mark. And then we took our marks and made a box at all 4 corners. We cut out. And once we cut these sections out, we were left with flaps. We took and folded the flaps up, leaving a box on the bottom and 4 sides. And so we did that. So we pretended our piece of paper was 8 by 10 inches, 8 inches wide, 10 inches long. So our length was 8 minus 2x. Our width was x. And our height, well, our width should have been 10 by 2, but 10 minus 2x. And the reason why is 2x, the amount we cut off was x. All right? So at 1 inch, 8 minus 2 gives you 6. So if we do 6 and 1, 2 times 1 is 2, so that gave us 8. That gave us 48 inches cubed. And then the next time we come around, we cut off 2 to give us 8 minus 2 times 2. That's kind of hard to see. Then times 2. Then 10 minus 2 times 2, which gave us 2 times 2 is 4. So that's 4 times 2 times 6, which gave us 48 inches cubed. Then the next time we came through and we cut 3 inches off, giving us 8 minus 2 times 3 times 3 times 10 minus 2 times 3. And so we got 8 minus 6 is 2, 3 times 8, 10 minus 6 is 4, 2 times 3 is 6, times 4 is 24. So we're trying to maximize the volume of the box, and this is what we cut off. So every time x change, and we use 3 different lengths. Okay, now let's look at building the biggest box, activity 1.3. The volume x in cubic inches of the open top box is a function of the side length x, blah, 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 blah. So if we look at what we did in the paper cutting activity, and you can do this at home, just take some paper and cut it open. So volume of an open top box is equal to the length of paper you use, whatever the side length is. So if the side is 8, you subtract 2x, because you cut off 2 lengths, times x, times the other side, if you use an 8 by 10 inch piece of paper. Okay, that's our expression. And then we put this into the calculator. So now, those of you who downloaded Calculate 84 or use some other TI 84 simulation, this is an app you can put on your phone or your personal iPad. There are other ones for the internet. So we're going to hit the Y equals button. And we're going to put this in. So parentheses is over the 8 and the 9. 8 minus 2 xt theta n. This button, xt theta n. And anytime I put something in a square, it's a button on the calculator that you press. It's right next to the green button, the one that says alpha. Xt theta n again. Close it, open another one, and 10 minus 2 xt theta n. Close the parentheses. And what you're going to do from here is hit the second button, the blue button. Hit graph at the very top right. And you will see the table of values. So when x is 0, x is 1, x is 2, x is 3, x is 4, you will get the volume of the box. Now, what we did in class was we did something else. We did second window to change the table setup. This will take you to the table setup menu. And you go down to Delta Table. So you go down with the arrow button on the right side. You go down 1 to where it says Delta Table. Change this to 0.5, 0.5 or 0.5. And then hit second graph again. And what this will do is this will make the values, the x values change. So you get 0, 0.5, 1, 1.5, 2, 2.5, and so on and so forth. And then you can look at the volume and you can see how the volume of the box can be maximized for the right x length to give you the largest amount of volume for the amount of x that you cut off the sides of each side of the piece of paper. Okay, so try to do this. If you have scissors and a ruler at home, try to cut out some paper. Cut the corners out. Make sure you measure each side, like I showed you before, and you can try it. And then you fold up the flaps, and you'll see that you'll get boxes. Okay, looking at the Are You Ready for More? Usually I won't go over these unless it's something pertinent to what we do. But this asks about surface area. Surface area is another equation. You will use that in geometry. I'm not going to touch surface area here. Okay, now here's our lesson summary. Please look at the lesson, read through the lesson summary. This is a good highlight or explanation of the lesson, of the aims of the lesson in words to explain what we did. So you can see we cut out the corners by measuring 1 inch this way and 1 inch this way, or whatever distance. We cut it out, and we did the same thing to all 4 corners, and then you fold up the flaps. So what's inside the box becomes the bottom of the box, and this area becomes the sides of the box. Okay, and we're going to talk about the graph of the function later, but at some x will maximize your volume, and that's the whole point of this exercise today. So we just did it graphically, we did it algebraically, and we did it physically. Thank you for watching this video. I will see you in class.